Helps if you know C. Helps if you learn about system fundamentals. DTrace wins. So to comprehend why you're using it and what the result is, the best use of DTrace is to find unnecessary work, not to actually tune something in particular. So having deep visibility often finds work being performed that's just not needed. So on the Fishworks storage appliances, we're using DTrace to show you which clients are accessing your filer, what files the clients are accessing. It's very high-level information, and it often lets customers discover that there's some client abusing the filer that shouldn't. There's some client accessing a file too frequently that it shouldn't, and can eliminate that work and get a huge performance gain. Solving performance issues, being able to measure where the latencies are, show what the costs are, for your more typical performance wins, 5%. Finding bugs, DTrace is great for that. We've used it many times because I can see how library interfaces are called. Maybe people are misusing arguments and flags. So it helps you. You can also look at the error status of any function. If you have an application that's just dying in a strange way, you can use DTrace to go through the error path. See who's generating that error and how it gets handled. Proving performance issues is quite valuable as well. Proving who's to blame. And some example scenarios so we really get our head around it. In the past, a customer may say, why is our system slow? With previous observability tools, customers could often find problems but not take the measurements to prove that they found the problem, such as what is the latency cost of the issue. The application vendor may respond and say, the real problem is the database. The database vendor says, the real problem may be the OS. The OS vendor says, no, the real problem is the application. Anyone been in this blame wheel before? Yes, yeah.
But the OS vendors and the database vendors all agree it's really the user's fault.
And I need to improve my blame wheel and include users in there as well, that's right.
We could only get rid of all
We all know the problem stops with the user, right? It's always the user.
It's always the user. Well, actually, no. This problem exists because it's difficult to prove quickly where the fault lies, especially with you've got closed source software. You may not have debuggers to look inside it. DTrace makes it easy because you can look inside any software, even if it's closed source, even though the software vendors probably don't want you to. You'd better read their terms and conditions of use. But you can definitely look inside it and prove where problems lie. In the past, customers can say, I think I found the issue in the application code. The application vendor says, that issue is costly to fix. We're happy to fix it so long as you can prove it's the issue. So the application vendors are trying to help out. They need to cost justify the engineering effort to fix this. And the customer needs to give them the evidence. This is definitely the issue. Please spend the money fixing it. The lack of proof can mean stalemate. A happy ending, in fantasy land maybe, the customer says, I measured the problem, it's in the application, and the application vendor says, I'd better fix that right away. At Sun, we are quite happy when customers use DTrace to prove problems like performance problems. I said in my earlier talk that there are lots of performance problems in the system. It's about what are the important ones. So if a customer has actually dug through it with DTrace, it's much more likely that they've found the ones you want to fix first, things that are really important. So you may be able to phrase it in terms of 80% of average transaction time is spent in the application waiting for user level locks. And the application vendor may say, well, we measured the problem and found it's actually in the OS. And the OS vendor says we'd better fix that right away. So 80% of our average transaction time is consumed by a bug in libc. Some initial questions. DTrace is not available for Solaris. And actually, I may stop getting asked this question, so I might have to remove it from my slide, but I was asked that question a lot when Solaris 10 first came out. DTrace is available for Mac OS X, of course, and FreeBSD, I believe, has an implementation, and it's spreading, which is great. You do need to be root or have the correct privileges to run DTrace. There are GUIs out there, one called Chime. Fishworks has got analytics, which sits on top of DTrace and KStat. It's safe for production use, that's what it was designed for, provided you don't deliberately try to cause harm. It has low impact in use and zero impact when not. That last one sounds suspicious. How can something have zero impact if it's a feature? So how it works is, actually, maybe I should demonstrate how that works. And some of you may have seen this done before. So, although I'm going to need to run mdb-k, so I'm going to need to log into a Solaris box, because I don't think mdb-k works on Mac OS X. Okay, and how about I DTrace BDEV strategy, something simple. So here you go. I'm looking at a kernel function called BDEV strategy, and BDEV strategy, when it runs, it does push q, mov q, sub q, push quad, etc., etc. When that function runs, it just runs. It's just a normal function I'm looking at, no big deal. Oops. I now DTrace it. I'm just counting how many times it gets run. It's changed. It's now int 0x3 at the start, where previously, if I just page up, it was doing a push quad. Oh no. We've actually patched the live kernel. DTrace has gone into the BDEV strategy function, which was just a normal function. BDEV strategy had no idea that DTrace existed, and changed the instructions. Changed the instructions to call int, which does a soft int, which goes and runs a DTrace routine. So that's how DTrace works, and that's how DTrace gets away with zero impact when not enabled for things like this. The dynamic part of tracing, because I dynamically turned it on this function, because it goes to that function address space in memory and live patches the instructions. And when I stop it, it puts it back to normal, else we panic and die. So Control C there. Oh, BDEV strategy was run 308 times whilst I had it running, and we're now back to normal. That bit's called dynamic tracing. And like I said, BDEV strategy had no idea that DTrace existed. DTrace comes along and starts to instrument it. And it can do that, for example, here, if I look at the kernel, I'm using wildcards. It can do it for lots and lots of functions. Basically every function in the kernel. I have here Control C. A bit of latency going from here to the wireless to San Francisco to... Whilst that's running, I'll do this on Mac OS X as well. They can have a race. So, yep, that's still running, all right. So there's 9,000 function entries I can trace in the Mac OS X kernel using DTrace. And Solaris is still going, come on. It's going to be more, it's going to be like 17,000. Once that actually finishes. Oh, we're in FBT IP. Hey. Oh, no. Who could not allocate memory? No, that wasn't DTrace. No. I would like to DTrace it, but I don't think this was actually DTrace. I've never seen that before, so this may be a GNOME terminal on the Mac.